Okay, so section 5.1 is on multiplying and dividing expressions with common bases. And so the first thing we need to keep in mind is the idea of exponential notation. Remember that b to the n is equal to b times dot 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 times b, so basically in b's. So if we had 2 to the third, that's 2 times 2 times 2. If we have x to the fourth, that's x times x times x times x. So if we wanted to evaluate one third to the fourth, we get 1/3 times 1/3 times 1/3 times 1/3, and that gives us 1/81st. So we notice we have to be a little bit careful, because if we have -2 squared, that gives us -2 times -2 is +4. But if we had -2 cubed, that's -2 times -2 times -2, which gets us back to being -8. But then, on the other hand, if we look at -2 squared, we notice now that negative sign isn't attached to the 2, so we get -2 squared is -4. And then, unsurprisingly, if we tried taking -2 cubed, that winds up being -2 cubed gives us -8. So we notice that if we have a negative that's not inside parentheses, it's going to be negative regardless. And if we have an odd exponent, it's going to be negative regardless. Then we also remember that if we have a couple of things together, if we had 3x squared, remember that's going to be 3x times 3x is going to give us 9x squared. But if we had 3x squared, that's just 3x squared. We notice that the 2 is only attached to the 3 if there are parentheses. So now if we're trying to multiply and divide expressions, we notice that if we're trying to take x to the fourth times x squared, we remember our exponent properties. We're going to get x to the 4 plus 2 is x to the 4 plus 2 is x to the 6th. And so in general, we're just using our old idea that b to the m times b to the n is equal to b to the m plus n. And if we have b to the m divided by b to the n, that's going to be b to the m minus n. So if we had x to the fourth divided by x, we think of that as x to the fourth divided by x to the first. So that gives us x to the 4 minus 1, which is x cubed. So if we were going to look at t to the 7th times t cubed, that would be t to the 7 plus 10, 7 plus 3, which gives us t to the 10th. If we had t to the 7th divided by t cubed, that gives us t to the 7 minus 3 is t to the 4th. So then if we have more complicated expressions, if we're going to look at something like 3x times 4x squared, we remember that when we've got coefficients and variables, those are going to get treated separately. we're going to take 3 times 4 times x squared, and so we get 12x cubed. And so if we had 7x to the third times 2x squared, we would get 7 times 2, x cubed times x squared, and that gives us 14x to the fifth. So, nice and neat.